everyone. Today I'm going to talk about Agentic AI. So I'm going to show some demo on Agentic AI which I have built on my own in my Windows PC. So the Agentic AI which I built is something uh, related to intelligence in the sense global intelligence agent. The purpose of this intelligence agents is to monitor the events across the world, whatever the events and then the trends occurring across the world. So this particular agentic AI provides us insights on the latest events occurring all over the world. Okay, let me brief about this Agentic AI. This is the Global Intelligence Agent, a practical multi-agent AI architecture for real-world monitoring. I used MCP and then LangGraph and then Groq. These are the major technologies or else functionalities I've used it, AI related stuff. So the MCP and then the LangGraph and Groq. Groq is one which is going to support us the LLM. Since we are not going to use our own Olama model, in the sense Windows PC, I had some kind of restriction in using the Olama model since it was not providing the best performance. So I went with Groq, which is infrastructure platform in which provides us uh, LLM support. It's like a cloud platform which supports LLM interference. So it's of best performance. So I've used this Grok LLM in order to build my agentic AI. Okay, so we are going to shift from normal traditional AI into agentic AI. The normal traditional AI usually it's response based, whereas the agentic AI is one which is going to act or else evaluate based on the responses provided by the agent. You can see here the life cycle of this agentic AI. So it gathers the intelligence and then it reasons out and then it generates information based on the reasoning, and then it goes for the evaluation phase. The generated information is right or wrong. So and then after the evaluation it acts in the sense it reports or else it provides us some kind of alert mechanism with respect to this particular agentic AI system. It's like an alert mechanism. I've set it up, and then this is observation in the sense we are going to observe observability in the sense we have brought in the observability using Langsmith, which is going to provide us uh, the monitoring stuff. So the global intelligence agent, these are all the workflow. This is the workflow I'm going to show up now. So the events which are covered across this agentic AI is earthquake related event, and then cryptocurrency, the current trends, and then the emerging technology information news, and then the events related to the natural disasters occurring across the world. So these are all the events we are going to cover up or else monitor using this global intelligence agent. And then in order to support that, we have built-in MCP servers, and then the LangGraph is the uh, which is going to support us for orchestration, the entire orchestration of this of the agents. Since it's a multi-agent system, it is going to orchestrate between the agents. So the LangGraph is one which is going to do that for us, and then the Langsmith is one which is used for the monitoring stuff, the LLM usage, and then the failures, the hallucination, everything will be monitored or else reported using this observability tool called Langsmith. And then Grok is ultra fast llama interference for real time reasoning. This is LLM for us. We're going to use it since we couldn't make use of our local llama model because of the resource crunch. Uh, so we went with Grok. It's a cloud-based LLM support in the infrastructure. We had it, so we have it. So we are making use of that. It's high performance interference for real-time reasoning. So going to the project architecture and modularity, since this this is the agent based, we have multiple agents in this in this particular agentic AI system, and then we do have multiple MCP servers, and then we do have tool calling from the MCP servers. We used to call a specific tool for the specific operations, and then we do have logs, and then we do have this entire dashboard uh, which shows up the entire flow workflow. Before going to this, let me show up my agentic AI system, how it looks. So this is what the screen looks like. So we do have earthquake alert. It's a scenario which we have kept for monitoring the earthquake related uh, events, and then we have kept crypto market alert in order to monitor the latest trends in the crypto market. And then we do have technology trend monitor, so the latest news related to a technology all will be covered across this particular uh, tech trend monitor. And then we do have natural disaster watch. So this one is used to monitor the disaster across the world, any kind of natural disaster. Apart from the earthquake, some other natural disaster, everything will be monitored through this natural disaster watch. So let me run one scenario so that we'll have an idea. So let me select one. Since earthquake alert, I'm going to select this one. Okay. So I'm going to use the LangGraph and evaluation as well using Langsmith. And then my model I'm going to use is Llama 3.3 70B versatile. And then I've already configured my Grok API key, and then uh, my Gmail delivery. What is my Gmail ID, and then my Gmail ID password, everything, and then here what are the MCP servers it is going to use. So this are all the set of MCP servers. So let me show up here the setup and the architecture. So this are all the MCP servers. Uh, MCP server one event underscore server dot py, and then this is the second server, uh, intelligent server. This is going to use for the additional insights after gathering the event using the MCP server one. And then the third MCP server is the one is going to perform the action like sending across email, or else sending an alert, or else log an alert, something like that, sending a message, telegram message, something like that. So there are three set of servers, and then these three MCP servers internally uses all free APIs. So, for example, the MCP server one it is going to use this set of APIs, free APIs, and then MCP server two. Here it comes set of APIs. Uh, so yeah, and then MCP server 3, it uses some set of APIs over here, you can see here. Then do have all free APIs configured. So so this is the six-layer agentic AI. We do have six agents. One is observer agent, and then the second one is researcher agent, and then the reasoner, and then the writer, and then the evaluator, actor. So out of this evaluator agent, it doesn't come across here in the sense it is not mentioned over here. Uh, this is going to be a langsmith. Since the evaluation will be performed separately, the hallucination checks, everything will be done separately, and then it is not shown up here in this architecture overview. So it is a six layer agentic AI agents used. Out of that, five have been mentioned over here. So let me run. Okay, this one. So I'm going to use LangGraph and the evaluation orchestrator. So there are six agents, and then Llama 3.3. This is the model used. These are the layers. This is the workflow. So let me kick off. So this is the live agent pipeline. It is using the land graph. You can see here it is running over here, and then the observer agent. It is done already, unless it has moved on to researcher, and then so it is done now. It has called four tools during this researcher phase, and then this is done. This reasoning is done by the LLM itself, not by the tool calling. MCP is not required for this phase, and then the writer phase, MCP is not required, and then evaluator phase, MCP is not required. Out of these phases, the phase observer phase, it requires two tool callings, and then it uses MCP. And then the researcher, it uses four tool callings, and then it uses MCP. And then the actor agent, which uses three tool calling and uses MCP serve. So these other phases are taken care by the LLM itself. The reasoning, and then the writing, and then the evaluation, everything is taken care by the LLM itself. You can very well see here the evaluation results, hallucination, it has got passed, and then the freshness, it is a recent information available. We fetched it using this agentic AI, all dates within the expected range, and then the pass result for the accuracy of the data. So it is pulling the right information, facts. So you can very well see the live log as well. This is live log generated. You can here see here everything in green, and then finally it reported into my email Gmail ID. I can very well see here. Uh, it has generated freshly my this report, global intelligence agent. So earthquake alert. So event summary, and the impact on assessment, and then risk factor, and then the recommended actions. So everything is recorded over here. So so this is one scenario we have covered. So likewise, we can go for some other scenario. Like can we try this one? Let me try this one. Crypto market alert. Okay, so you can very well see the live log goes on here. So what is the output, and any hallucination it is detected? No hallucination detected. It's got generated. Everything is done. So evaluation phases, all phases is successful. All phases are successful. Pass, pass, pass. So hallucination is passed, and then freshness, it is a recent one, and then the fact checks also passed. So it is going to give us the intelligent report, the market snapshot, and then the biggest mover. So it has shown Cardano with price of $0.2 to dollars, and then 24-hour change of minus 1.67%. This is the biggest mover. And then sentiment and risk, here you can see the sentiment and risk. What is this sentiment, and then the risk, and then the key takeaways. So you can see here, and then we can check the same in our Gmail, whether it has got reported. Yes, we got the latest email. So this particular email alert is performed by the third MCP server, action server, and then the analysis part is done by the intelligence server, and then the pulling of information, the live information, it is done by the event server. So you can try this natural disaster watch as well. Let me try this one. So you can see here live log. So how many characters returned, and then observe agent done. So three tools have been called by the observer, and then 15 tools have been called using the researcher agents. So there are 15 tools used for this researcher, especially for this scenario, this natural disaster watch scenario. Lot number of tools have been used, and then the reasoning has been performed here. 10 tools have been called, and then for the reasoning, and then writer, it uses zero tools. So whenever the number of tools is zero, it is performed by the LLM. Whenever it is the tool number is high or else more than zero, it is performed by the MCP server. So in this case, reasoning is done by the MCP server, one of the tools. Since reasoning is not enough performed by the LLM, so it goes for the additional reasoning with one of the tools of set of tools. So in order to have a fact check everything, it uses additional tools, and then you can very well see the evaluation results. Everything passed, and then you can see the report. So tropical cyclone 26/6 Australia, immediate evacuation emergency response measures is reported, and then USA, North Carolina, and then Alabama, USA, likewise Arkansas. Okay, this is all the information we have, and then let's see this email generation happened or not. See here, the same report got generated in my email box. So good. So everything is perfect. So likewise, we can see the live tool testing. We do have observation layer with different layers. So each layer has its tools. You can see here observation layer. There uh, we do have separate tools. USGS underscore earthquake. You can run this independently as well in order to check. Let me check this one. It will pull some information. Magnitude of 5.2. So Indonesia, it picks up 5.2 magnitude related to an earthquake. You can very well see here. The, Likewise, you can weather. You can see here separately running this tool. You can see the weather information. Likewise, intelligent layer. We can see here the separate tools. We can run this independently. How it fetches the result. So, so this is used for the analysis purpose. Additional insights. This is to pull the events, the current events, and this action. Just going. Let me see this action. How to send the message. This is a log event. So it has got generated the log. Okay. So the MCP server it calls a external API. So whatever we are calling is external APIs. I'm using free API tool calling since these are all provided for free as I shown earlier. These are all free APIs I've used in this Agentic AI system. So need not pay for it. So uh, so the MCP server is going to integrate with the free API and external tool calling, and then it fetches the result for us. So you can very well see here the layer one, uh, the earthquake API has been called, and then NASA EONet API, and the Hacker News, and then Coin Gecko API, and then OpenMeteor API. So this is the observe agent. In turns, it goes and reaches the MCP server, and then wherein the MCP server goes and fetches using that external tool calling APIs. Thereby, uh, these are the APIs integrated with this MCP server, event server, MCP server. Likewise, you can very well see here the intelligence layer in MCP server. So these are the APIs, free APIs have been used. REST countries API, World Bank API. So this specifically gives us economic indicators how it got affected. For example, any event occurrence, the economy will be affected as well. That so such kind of information is provided by the World Bank API, and then this is specific to GitHub, the technology trends, and then such kind of information pulled from the GitHub API, and then research papers. So the it is pulling from the ARXIV API. So this is additional insights for the reasoning, deep AI reasoning. So this is very critical layer. This also critical. This is the first layer, and then this layer it provides more insights, so that more of reasoning uh, will be performed by this layer. And then the third layer is action MCP. This is something to go with the alert mechanism, or else some kind of fetching the results. So it's monitoring, or else log generation, or else email alerts. Such kind of events are performed by this layer MCP server. So action underscore server dot py will perform these services, Logger services, WordPress, and then Telegram and NTFY, instance push notification for market alerts. And then why we use Grok Cloud over the local execution. I already said that's a restriction in usage. The CPU restriction we do have when we use Llama model, the performance is low, and then the latency, the latency problem we have, and then the model accuracy also comes down when we try to use in our own laptop or else Windows desktop. So uh, the the higher the model, the higher the accuracy. So since it's a multi-agent pipeline, we need to have accuracy. We look for a bigger model, large model. So we went through with Llama 70B local model, which is used through Grok's LPU hardware. As I said earlier, it's a separate hardware infrastructure cloud provider, so that we need not go and install the GPU. We do have only CPUs with us locally. In order to go with the GPU, we need additional plugin to be installed, or else put across in our motherboard. So instead of going for that method, with that method, we just go and use our Groq's LPU hardware, pay for it, or else we do have a free version. So I'm using the paid version. So Groq's LPU hardware, it is good with this Llama 70B model in fetching the results. And then the orchestration observability, as I said earlier, the entire orchestration is performed by the LangGraph. So one of the good things about LangGraph is that it's it's good reasoning, and when you use LangGraph orchestration, so it is the deep reasoning is expected when compared to other orchestration, uh, like LangChain or something else. So for good reasoning, deep analysis, you go with LangGraph orchestration. And then the Langsmith, as I said earlier, it's for debugging and then traces and then monitoring stuff. So what are the tokens used, how many tokens used, and then what are the failures. Everything will be seen or else recorded in this Langsmith diagnostic tool. This is called the observability tool. And then so we can see here the evaluator agent, what would be the results, the score, and then the hallucination checks, everything will be performed or else reported. So here it is showing as none, the hallucination is none. And then this is the end-to-end system architecture. So external APIs have been called by the two layer. And then this is the MCP server. Each MCP server, it goes and interact with the external API. So the first layer, the first MCP server, second MCP server, third MCP server uh, connects to the corresponding external APIs and then fetches the results, and then uh, goes through LangGraph agent workflow, and then finally the Llama model is used for the reasoning, and then the evaluation layer we do have separately here, and then the final real world action, in the sense we do get the result at the end of evaluation layer. So these are all things. Dynamic routing, we do have dynamic routing for the earthquake alert. It goes with the observation layer, even to the score server, the MCP server, and then it bypasses the second layer for the earthquake alert, and then it directly fetches the result. And then in case of crypto alert, it goes through event server, and then intelligence server, the second MCP server, and then the third as well. So it uses this specific tool calling, uh, GitHub trending by the research layer for the crypto alert, and then the notify underscore NTFY, the action layer. Likewise for tech trend, it uses researcher layer is open alex underscore search tool calling, and then post WordPress action layer it uses for the tech trend. So that's all I have. Let me show up the Langsmith. Okay, Langsmith. I do have Langsmith as well. Okay, no problem. Let me show in future demo the Langsmith how the observability tool looks like. So that's it from my end as of now. So thanks for watching.